This conference will now be recorded.
Fine. Can you see my screen, everyone?
Yes, sir.
Yeah, we are working on Kubernetes. We set up Kubernetes yesterday, right? So cluster setup we performed yesterday, right? Yeah. Today we are going to perform some deployments. Okay. So before going to deployments, we have some important components, deployment components. What are those? We'll try to understand. So what are the components available? Okay. Yeah, key components of Kubernetes. Key components of Kubernetes. First one is pod. So pod is very important. Okay. What is pod? What is the use of pod? Okay, where we use this pod and what is the functionality of this pod? Okay, so we'll try to understand. Pod is a atomic unit of scheduling. Just a minute. Yeah, pod is a atomic unit of scheduling. What is atomic unit of scheduling? Okay, so let us try to understand what is atomic unit of scheduling. For example, we have virtualization concept, we have Docker, also we have Kubernetes. So in these three environments, okay, this is virtualization. This is virtualization. So this is the Docker. This is Kubernetes. Three different environments, three different layers. Okay. So Docker is advanced to virtualization. Kubernetes is advanced to Docker, right? So in virtualization, what is the atomic unit of scheduling? What is nothing but atomic unit of scheduling, right? So atomic unit of scheduling means in virtualization, so when you want to create, when you want to configure any applications, when you want to deploy the applications, okay. So here in VM we deploy, right? In VM only, virtual machine only we deploy all the applications, all the configurations, right? So atomic unit of scheduling is VM. In virtualization, atomic unit of scheduling is VM, right? So in Docker, atomic unit of scheduling is container. So container lo మనం deploy చేస్తాం. If you want to deploy any applications or any configurations, we deploy on container only, right? And next one is Kubernetes. In the Kubernetes, atomic unit of scheduling is pod. So it's interview question. This is interview question. Okay. So what is atomic unit of scheduling? Interviewer will ask you this question. So when I attend some proxy interview last time, I faced this question. So in Kubernetes, what is atomic unit of scheduling? Atomic unit of scheduling is where we deploy application. Is nothing but atomic unit of scheduling. It can be pod, it can be container, it can be microservice. Where we deploy applications, where we configure application is nothing but atomic unit of scheduling, right? So it's interview question. So last time I faced this question for one guy. I attended a proxy interview. So by the time I got this question, right? Next one, how these pods are deployed. So let us try to understand how these pods are deployed. How the pods are deployed. So before going to deployments, we need to understand this. That is why we are discussing this. Yeah, how the pods are deployed. Let us try to understand. Yeah, first, if you want to deploy any application in Kubernetes on pods, okay. So very first thing, we need to prepare .yml script. That is nothing but manifest file. So here we need to prepare .yml script. Yeah, we can say .yml file. This is .yml file, and this is called manifest file. Manifest file. Okay. So once we prepare this, for example, you want to deploy some web server, Apache Tomcat server. You want to deploy. Okay. So first we need to prepare .yml file. That is nothing but manifest file. So once we prepare that, so we need to submit to API server. Where the API server will be available? Master. Yeah, master node lo untadi, right? So it will be available in Kubernetes master. So this is API server. So once we submit this API server, okay, so it will send to scheduler. Scheduler will distribute the equal load on node servers, which are available in the cluster. Okay, so we submit to API server, then the deployment will move to cluster. For example, this is cluster. This is cluster. Inside of the cluster, we'll have node servers, different nodes. This is node. For example, this is node. Inside of the node, we'll have pods. Like this, we'll have different pods. Right? So inside of the pods, what will be there inside of the pods? Containers. In the container, we deploy the application. Yeah. This is cluster. This is a node. This is a pod. And this is inside of this, we have container. Right? So the deployment will be happened like this. Okay. So when we submit YAML script, YAML file, manifest file, it will move to API server. So after that, it will move to cluster. Inside of the cluster, we'll have different nodes. So this is one node. So inside of the node, we'll have pods. Inside of the pods, we'll have container. So in the container, we deploy the application, right? Any questions in this? Yeah. Next one is pod networking. So how the pod network will be happen? Pod networking. Fine. So we have two parts. For example, we have one node. This is one node, for example. Okay. Inside of the cluster, we have one node. Inside of the node, we have two parts. This is one part. This is another part, for example. Right? Now, next one is inside of the pods, we'll have containers, right? So this is the node. This is pod 1 and pod 2. We have two parts. Inside of the parts, we have containers. This is one container. This is another container. The same way, here we have one container only. So it can be one container or more than one container we can create inside of the pods. We can create two containers or more than two containers, or else we can create only one container inside of the pod. Okay. So in Kubernetes, we don't talk about containers. We always talk about pods. Okay. So now, so this is main. Yeah. Here these are the containers. This is main container. So this is the supporting container. This is main container. Right? So every pod will have one IP address. Every node will have one IP address. Also, every pod will have one IP address. Okay, fine. This is a node IP, for example, 10 dot. Node IP 10 dot 10 dot, yeah, 10 dot 1 dot 1 dot 0, for example. This is node IP. So every pod will have IP. Again, every pod will have IP. So this pod is having some IP address, which is 10 dot 0 dot 30 dot 50. This is pod IP. So this is also pod IP. This pod also required one IP 10 dot 0 dot 30 dot 60. Okay. Now, if you want to deploy any application on a container, okay. So once, yeah, for example, using manifestation, we can deploy. After that, if you want to access the application, how can we access? So every container will have port number. Okay. So this is port number. Like this container is having one port number, like 8080. This container is having port number like 3000. This container is having one more port number, which is 7777. Okay. So how can we access this application? For example, so we deploy some applications on this container, first container. How can we access this application, right? So here, if you want to access this application, for example, in this you have deployed some application which is Tomcat. Okay, here you deployed some application which is some web application, web app, something. Here you deployed something like some Hello World application. Something, right? So now, if you want to access this application, whatever application is available on the main container here. So how can we access once we deploy that? From here, first we give node IP. Node IP is 10.0.10.1.0 colon this port number, this container port number 8080, right? So that you can access whatever application is deployed in this. So normally this is the backend process. Okay. So as the DevOps engineers, okay, if you deploy any applications, if you perform any deployments, by the time backend we can check like this using node IP and the container port number we need to give, so that the application will be accessible. Okay, and also in this web server, if you deploy an application here, how can we access? Yeah, same here also, node IP 10.1.1.0 colon port number 3000, right? Then this application will be accessible, whatever application, web app application you install, so that will be accessible through this IP address and port number, right? The same way here also, if you want to access this application, okay, so this is also you can access like IP address of the node and port number of the container. Node IP, so 10.1.1.0 colon 7777. So this is the way normally in real time backend we can access our applications, whatever applications deployed on the pods instead of the pod containers, container port number and node IP. Node means our Kubernetes node, right? So in the cluster, nodes will be available, right? That, right? Fine. Like this, we can access our applications, whatever applications we deploy, we can access like this. Okay. Yeah. Now, interpod network also it would be same. Okay. So yeah, below this will give some. Below this we give some network routers. Okay. So that is not required. So directly we can go ahead and deploy the applications. Okay. Any questions in this? Questions before moving.
Sir, every pod we need create main container, support container is mandatory.
It's not mandatory. It's not mandatory. Okay. So it can be one container or more than one container we can create instead of the pods. Okay.
Based on requirement.
Based on the requirement, exactly. So మీరు ఒక pod లోనే multiple applications you can deploy, or else. Okay. So one pod, one container you can create and one application you can deploy based on the requirement. Okay. Fine. So let us go and start our servers. Yeah, pod IP also required because pod communication. So networking will be there instead of the nodes. Will create pod networking. Okay. So one pod to another pod, if you want to communicate, we required pod IP, right? So Kubernetes lo మనం create చేసాం కదా networking. Sorry, in Docker. In Docker we created some networking, right? The same way here also we'll have networking. Kubernetes networking. So pod to pod communication we can establish. Now let us connect our master server. Node server is no need to connect. You can connect master. Yeah. Now su sudo su so su just quickly open this document. Yeah, this is the command. Sudo space su space hyphen kubeadmin. First we need to switch kubeadmin. Kubeadmin. Yeah, now we switch to Kubernetes admin. Okay, so here what we will do, we can create some deployments. Okay, now deployment document I'll show you. Yeah, so these are the deployments. See here, this is the YAML script. This is YML script. Using this, we can deploy the application on Kubernetes cluster. Okay, so here if you see API version, which is apps v1, find deployment, metadata, name, nginx deployment, labels, application name, nginx, spec means specifications. Okay, so replica one means one replica, one deployment, one container. Okay, not container, one pod. This is one pod. In place of this, if you give five pods will be created. Okay, so for now we can create one pod. After that we can scale that. We can scale up. Scale means pods will be increased. What is auto scaling in AWS? Auto scaling and
Auto scaling nothing but
yeah, whenever
increasing the
we
size.
require, yeah, based on the application utilization. So servers will be scale up automatically, right? So the same way here, pods will be scale up. We can scale manually. Also, we can configure auto scale up. Okay. Next one, template metadata. Next one is containers. So this is the container name, Nginx image name. We require one image. This is the image Nginx 1.14.2. So container port number. Why we require this container port number? If you want to access your application, we require some port number, right? This is a port number to access your application. Fine. So this is the manifest file. So using this, we can deploy the application. This is the Nginx is a application. We can deploy this first. After that, we have Hello World also, Hello World application. Or else we can use Apache Tomcat. So these two applications we can deploy, Apache Tomcat, also Nginx. These two applications we can deploy now. So let us go and create one manifest file here. So if you want to create manifest file, vi file name nginx dot yml. So yml is mandatory. Okay, without yml can't run this file. So in Ansible also we use yml, right? The same way here also we use extension would be yml, but here this is not actually YAML script. This is manifest file. You can call it as manifest file. Okay. Enter. Now you can copy paste this YAML script. Copy this. Paste here. Here A is missing. You can give A API version, right? API version, apps v1, kind deployment, metadata, yes. So this is the image, this is the title port number. Escape, shift column, save and quit, WQ. Okay, it is saved. Now if you check ls here, this is the deployment, nginx.yml. Now once we create the file, okay, next we need to deploy. We need to create deployment, okay, for which command here is kubectl create deployment, kubectl create deployment space hyphen image name is nginx space. So custom name you can give, okay. So image name Nginx. If you want to give custom name, you can give. Custom name is my Nginx. I'm giving my Nginx. Okay. kubectl create deployment. Image name, custom image name. Enter. Now the deployment is created here. So once we create this deployment, now if you check kubectl get pods, kubectl get pods. So one deployment is available here. See here, we created one deployment, right? One pod is running now. This is pod. This is the command to check the pods. When we deploy any application, so one pod will be created. This is the pod. kubectl get pods means one by one means one pod. It is in running state now. So this is the pod name. Okay. Fine. Next one is once we create the pod. So if you want to check deployment, you can check. Command here is kubectl get deployment. Kubectl get deployment. See here, this is the deployment, right? So we give custom name, right? My Nginx. This is the name. So available one pod, 59 seconds age. Okay. Now, so once we create the deployment, after that we need to create one service. So before that service, currently we have only one pod. Only one pod is available, right? I want to scale this because if you create one pod, So fault tolerance, like scalability, fault tolerance required, right? Scaling required, scalability, fault tolerance also required. For example, you deployed a real application. If you deploy only one, deploy the application on only one part, what will happen? If the part is corrupted, if the part is down, entire application will be down. So that is why normally in real time we don't deploy application on single part. We deploy the application on multiple parts. Right? Now I want to scale the deployment. So command here is kubectl scale deployment. Kubectl scale deployment space hyphen replicas space. I want to give 5 replicas. 5 replicas means 5 parts. It would be 5 parts. 5 parts will be increased. Okay, space deployment name my Nginx. Enter. So now it is scaled. Now if you check kubectl get parts, how many parts are there?
5.
5 parts. So we scaled this application. So now the same name, 5 parts are increased, right? We scaled up. We scaled the parts. Now if you check kubectl get deployment.
Sir, total 6. We are creating 5. Sir, previous one is already available.
No, not like that. Kubectl scale deployment replicas up to 5. Up to 5 means we have one part, so we increase to 5, maximum 5. kubectl get deployment. Now in the deployment, so these are the parts. See here, 5 by 5 1, 5 by 5 means parts. 5 parts are running, right? Now, so once we scale the parts, now we can create one service required. So these are the steps we need to follow. Okay. So next we need to create service, for which command here is kubectl create service. kubectl create service space node port space your deployment name my Nginx space hyphen TCP port TCP equal to 80:80. Okay, so this is the command to execute to create service. kubectl create service node port space my Nginx is the application deployment name. So space hyphen TCP equal to 80:80. Okay, and then now service is created. Now if you want to check the service, kubectl get service or SVC. You can use SVC also. Okay, see here, this is the service which we created. So when we create service, this is the service. So this is our port. This is actual port, right? 80, our deployment port here, right? Container port. Now one more port is generated by Kubernetes, which is 30120. Using this port, we can access our application, right? Now, so this Nginx is deployed. Now I want to access this application. Okay, so to access this application, I'll access now. How can we access?
Node IP.
Node IP and port number, right? Fine. Go to browser. This is the port number 30120. Give the node IP. And port number 30120, right? Right. Enter. See, welcome to Nginx. Okay, so this is not fully configured application. This is not fully configured application. This is a test application. Just it will show you welcome page. That's it. So we prepared like that for testing only. Okay, this is not real application. It will show you some web page, welcome page. Okay, so if you give wrong port number here, for example, 30121, for example, 30121, if you give like this, it will give you error. It will not open. See here, this site cannot be reached, right? So exactly same port number we need to give, then only we will be able to access, right? So can you try from anywhere? We can access this. I ping this URL. Can you check? Can you try? Can you click on that? It will be open. Welcome page. Can you try now?
Yes, sir, we are able to access.
Able to access, right? From anywhere we can access. From anywhere we can access this application, right? So this is one of the application deployment, and also we can deploy one more application, which is Apache Tomcat. So I'll provide you these commands, all these commands available here. So these are the commands I provide you. Whatever commands I executed, these are the commands. Next one is Apache Tomcat also. You can use this application. Copy this. Now, vi httpd dot yml HTML. So this is the application. Okay. API version, apps v1 beta 1, kind deployment, metadata, name, my Apache deployment, and spec replicas, pod replicas. Only one is there. So template, metadata, and application name, my Apache, spec for containers. This is the container name, and image name is HTTPD. Okay, port numbers are again we give 80. So Kubernetes will generate customized port. Using that, we can access the application. Right? Fine. Now I want to deploy this application. Escape, save and quit. Right? Next one is first we need to create the deployment. Right? Once we create the file, you check ls. We have two deployments here. I want to create deployment first, for which command here is kubectl create deployment space hyphen image HTTPD, right? HTTPD space my HTTPD. I'm giving my HTTPD. The custom name I'm giving like this: kubectl create deployment hyphen image HTTPD my HTTPD. Enter. Now the deployment is created. Next one is now we can check the pods. Kubectl get pods. So these are the pods available. So this is new pod which we created for HTTPD web server, right? So these are the Nginx pods, right? All are running state. Now, if you want to check deployments, command here is kubectl get deployment. So we have two deployments. So Nginx and HTTPD, right? So Nginx we are having 5 parts. My HTTPD having only one part, right? Now I want to scale up this. This one also I want to scale up. My HTTPD also I want to scale up. The command here is kubectl scale deployment space hyphen replicas. So I want to give 3 replicas. I don't want to increase to 5. I want to increase to 3 replicas only. Okay. Space my HTTPD. Enter. Now it is scaled. Application is scaled. Now if you check kubectl get parts, we have 3 parts are my HTTPD parts and other 5 parts are Nginx parts. Total 8 parts are available, right? Now I want to check service here, deployment kubectl get deployment. So we have HTTPD, Nginx. In HTTPD we have 3 containers, and Nginx we have not containers, parts, 3 parts, 5 parts. Okay. Yeah. Now I want to create service. Finally, we have to create service. Using our service port, we can access the application, right? So to create service, command here is kubectl create service space node port space my HTTPD deployment name space hyphen TCP equal to 8080. Okay, enter. Now service is created. Now if you want to check the service, command here is kubectl get service or SVC. So these are the services created. So we have 2 services here, right? HTTP service and also Nginx service. Okay. Now I want to access this my HTTPD application, right? So now you can take public IP of the node, take public IP, any node, this node or any node you can access because both the nodes are in cluster, right? So any node IP you can take. So copy this public IP, paste here, and also we required service port number, right? So this is the port number 32582. Enter. It will give you output. It is simple application designed like this. It is not accessible.
Sir, both will not communicate, sir, right? Yesterday IPs are changed.
No problem. Public IP. Can use public IP. That's it. Nothing will be hacked. 32582. Okay. HTTPD somewhere I think. You can use master IP also. So let us try. Master is also in cluster, right? Let us check this IP. kubectl get pods. Pods are running. Yeah, running state, right? kubectl get nodes. Yeah, nodes also ready, right? So these are in running state. Cluster is currently running state, right? So let us check. I think somewhere we did some mistake in the deployment somewhere. So copy this node IP over here. kubectl get service 32582. 582.
Semicolon
Okay,
again.
yeah, 2 times ID, right? Okay, in the deployment, so somewhere, yeah, quickly we do one thing. I create one more time quickly. So if it is working or not, let us check quickly. vi httpd 1.yml. Just paste this quickly. API version. Okay. Escape. Save and quit. kubectl create deployment space icon image httpd. Here we can give same httpd1. I'm giving httpd1. Enter. So deployment created. Next one is you can scale up this kubectl scale deployment icon replicas. So I can give 2 replicas at this space httpd1. Enter. Now kubectl create service node port httpd1 space hyphen TCP equal to 8080 colon 80. Right now kubectl get service. So another code is generated here, which is this one 31569. You can apply this 31569. 569. Now this is accessible. See here. So this is the output basically. It works just a simple output, whether the application is accessible or not. So we designed like this. We prepared our custom manifest files, deployments. So this is not real application. If it is a real application, it will be open web page, right? So we designed like this. We prepared customized manifest file for the testing role. Okay, you can test it. It will show you same output. It works means just output. It is working fine. Can you click on this URL so that you will get output?
Sir.
You're getting right? Yeah. This is the way normally in real time we deploy applications. Whatever applications we are using in microservices. So normally this is the way we deploy the applications. So backend we will check like this using node IP and port number. Okay. So I share this deployments today. You can try once. Also Kubernetes deployment YAML example. Just type like this, you will get so many deployments. You can go to official site. You will get sample deployments. So you can try this. See here. This is Nginx, which we used. Nginx deployment. So these are the different deployments. Right? So you can search like this, you will get so many deployments, different deployments. Okay, so that you can try different deployments. See here, they explain like this: API version v1 kind pod, right? So this is the name, metadata. This is the syntax. See here, this is full application, same application, Nginx. This is another one, front end, image name is Nginx only. Like this, we'll get so many deployments, different deployments. So these are the commands. See here, these are the commands. kubectl get pods. If you want to delete pod, this is the command. kubectl delete pod and pod name. kubectl describe pod. If you want to search the details about pod, you can use this. So like this, you can try your own. Tomorrow we'll have different activity. So we'll work on different activity tomorrow. Okay, I'll share this document. You can execute this deployments and you can try. These are the commands which we executed today. You can try. And tomorrow we'll work on different tomorrow day after we'll have different activities. Okay, we'll work on that. Fine. So any questions, anyone? After creating replicas, how to configure those, how to load move to other replicas. So we'll see that going forward. We'll have another 2 sessions, 2 or 3 sessions. In that we'll understand that. Okay.
Sir, inside
Fine.
pod, how to create containers like we are discussing.
We don't create container, automatically it will be created container. I'll show you tomorrow. So already
Okay.
container created. Instead of the pod, containers are there. Okay. Tomorrow I'll show you that.
Okay, sir.
Fine. Yeah. We stop here for today. You can practice this. Tomorrow we'll work on different activities. Fine. Thank you all.